G'day and welcome to part 2 of my walkthrough through Practice SAC 2, the 2019 Dandenong SAC. The company that is providing the t-shirts to all the runners in the half marathon is undertaking a break-even analysis by considering the costs and revenues involved. The revenue is based on a fixed number of t-shirts and how much they are sold for. They are sold for $30 each. The costs include a fixed amount of $3,800, which covers the design, the machinery, staff wages, plus a manufacturing cost of $4.50 per t-shirt. So what we need to do is we need to create an equation to represent the cost of making the t-shirts. So let's go. Yeah, we'll say the cost of the t-shirts is equal to 3,800 because that is your fixed costs plus 4.5x, where x is t-shirt numbers, t-shirt hashtag. Write an equation for the revenue from the t-shirts. Well, the revenue is how much money they make for selling each t-shirt. Well, in this case, R is going to equal to 30x, where x is the number of t-shirts. What we need to do now is we need to graph this situation on our CAS. Graph the cost and revenue equations on the axis. So this isn't a minimize, maximize, optimize problem. This is a simple draw two graphs and see what happens. So in this case here, 3,800, obviously want to make sure that my CAS is in the right form. 3,800 plus 4.5x, and the other one is at 30x. Now, obviously, when I draw it, I'm not going to be able to see anything. So what I need to do is make my life easier so that I can more accurately graph it, because I have to take this graph and put it on the page. I'm going to play with my window and I'm going to match what's on the graph. And in this case, it is going to be an x minimum. We'll say minus 10 because we want to have that little bit of wiggle room. We're going to have a maximum of 350. We'll go 360 because we want to be able to see it all. And it's going to have a scale of 50. And for our y minimum, we're going to say minus 10 still. And the y maximum, we are going to say is 8,000 because that's the highest point on our axis. And we're going to have a scale of 2,000. So we're going to hit OK. And we get this. All right. So we now need to take this graph and we need to put it into our equation here. So what we're going to do is we're going to use the trace on the CAS to find us some points. So we want to find 0 on this one. That's obviously 3,800. So that's 3,000 here, 3,500, 3,800 is going to be about there. And now we want to go back to the CAS and we want to go all the way across. Let's go to 350 because, again, we only need a single point. If we have a single point, we're golden. 5,375. So that's 5,000, that's 5,500. So it's going to be halfway between there. So I'm going to say it's about there. And then I'm going to get my ruler. And I'm going to, as best I can, draw a line right through it. And then this line is going to be equal to C equals 3,800 plus 4.5. X. And now we need to go to the other one, get some more information. This one starts at 0, 0. So we need to find a point of data that we can work with. So let's say we'll go 200 because that should be a nice even number, which it is at 6,000. So I'll change colors to make it easier. We've got that point there, and the other point is clearly 0, 0. Get our ruler out again. Obviously, it's a much steeper line. And it will go off the axes. And then that line is obviously R equals 30x. Oh, well, I've clearly shown it to my teacher because I am my teacher. Now, what's important to realize is that we are going to care about this point here. All right. This point here is our break-even point. And I'd be shocked if the next question didn't say, calculate the break-even point. Oh, look at that. So, Kaz. Analysis, G-solve, intersection. Bingo, right there. The intersection point is at x equals 149.01961, and it's at $4,470.5882. So that's the break-even point. So how many t-shirts do they need to sell to break even? 150? Because you can't sell 0.01 of a t-shirt. And if you only sell 149 t-shirts, have you made profit yet? No, you haven't. So you have to round up. So we'll say 150 shirts. One marathon organizer suggests offering the first 200 runners to enter the event at a discount of $15, 15% for the t-shirt. How does this impact on the break-even amount? All right. So this is going to be, we're going to need to do a couple of things here. We're going to need to take the graph and we're going to need to split it. So obviously the costs of making the shirts haven't changed. So it's still that 3,000 and whatnot. So between 0x and 200, the gradient is only going to be 0.85. So it's going to be 15%. So minus 15% of 30. So we're going to take that point, we're going to times 0.85 by 30, and that will get our new gradient. So we're going to go 0.85 times 30. Put that in brackets because this is going to be our new gradient. But what we also want to do is we also want to make sure that the graph is only between 0 and 200. Now, by doing that, what we've done is we've actually found that by modifying the price, we still reach the break-even point in that first 200. So what we would then do is we would go analysis G-solve intersection, and we want to find between blue and green. And in this case, it's 180.1. So in this case here, we would have to say they need to sell 181 shirts instead, right? Based on what we've got here, because that's where this new equation crosses the break-even line. Another organizer suggests that rather than offering a discount, the first 60 people don't pay. Okay. And then the rest pay full selling price. Which suggestion has a better profit margin? All right. So this is going to be another graph in two parts. So all right, this is how my mind works. So between 0 and 60, the gradient is 0. But 60 and up is going to be that $30 again. So what we now need to do is we're going to have a line of gradient 30, but it starts at 60, 0. So 60, 0, m equals 30. So y minus y1 equals 30 bracket x minus x1. So that's y equals 30 x minus 100 and 1,800. 1,800. Not that big, but yeah. So we can technically go in here and we can define on our CAS one line. So I'm going to go into math 3. Third one down, fourth one across. I'm going to do this. So it's 0x between 0 x 60. And then the next one is going to be 30x minus 1800, where 60 So if we look at the line there, we can see that the green line. Now remember, I didn't actually finish drawing the green line because after the green line, after 200, what happens to the price? It goes back to normal. So to finish off that line, we're going to need to do an extra step that I didn't do before because it wasn't required, but we still need to be able to do it. Because to help us make the best decision possible to answer this question, we get to 200. The graph falls off, obviously. Oh, because I defined that it doesn't equal that. So we'll pop that in there. That's 5,100. So at 200, 1,500, the graph takes over. The graph will take over. So I'm going to make another note on the side here. So 200, 5,100, comma that, because that's going to be important. So I have y minus y1 equals 30 bracket x minus 200. So that's y minus 5,100 equals 30x minus 6,000. So that's y equals 30x minus 900. All right. So we can go back to our CAS, because we want to remember the question says which suggestion has a better profit margin, which one is going to make the most money. Now, I can tell that it's going to be my green line on my graph. It's going to be the green line. I need to be able to demonstrate why. So if I go back to my graph, and I'm actually going to make this piecewise itself. And then at 200 less than or equal to x, it's going to use my new equation, 30x minus 900. Now when I draw these graphs, now that I've drawn these graphs, you can actually see that once it gets to that certain point, the graph then kicks and changes angle again. So if I trace the green line, it changes. And now all three lines, the red, the green, and the purple, are all on that gradient of 30, which means they are parallel lines, which means they will never cross. So what you want is the line that is the highest amount above the purple line, above the blue line, sorry, because the blue line is our costs. All right. So from there, we can then say option. So which suggestion has a better profit margin? The original situation or part V? So I think there's a mistake. I think that's a mistake in the actual question itself. What we wanted was which one is better, this one or this one? And in this case, it's this one. Because if you look on the graph, the green line is basically always above the purple line. It does shift the break-even point, but green is better because you need less people to meet those requirements. So just another way that the t-shirt price can be used as an incentive for early entrants. How does the profit margin for your suggestion compare to parts 4 and 5? Well, they mean 5 and 6. So this one is another open-ended question. You can design one of these yourself and do it however you want. All right? As long as you can come up with a reason that means they still meet all their costs, and they can still make a profit. Your job as a promoter would be to do all of this, but you would to create your own thing.